Hello everyone, welcome to Ilustraca. So in this lecture, I'm going to discuss about iterative P delta analysis, and we'll see how to apply this in Staad Pro. Right. So first of all, let us discuss the fundamental of P delta analysis. So see, uh, uh, suppose we have a column here. Okay, we have a column like this. Okay, and it is fixed at the support. It is having some you can say vertical load, okay, vertical gravity load P, and it is some horizontal load which is suppose V, okay, and the height of this you can say uh, which one I should take. Yeah, let me take another pen. Yeah, so height of this column, okay, suppose it is smallish, fine. So this is my condition where I have a you can say column, cantilever column, suppose in this scenario, and I have, you can say, the V lateral force acting on this and a P vertical force acting on, right? So generally when we will be estimating the forces, okay, estimating the forces and moments after the first order analysis, first order linear analysis, what we will be getting here. So after the first order linear analysis, we'll be getting something like this, that this was my, I'm trying to draw it again. This was my initial location, right, of the column. So due to this you can say V force acting on this, V lateral force acting on this. So it is displaced, and we are getting a displaced shape like this, right? So this V is still acting on it. V is still acting on it, and again this P is still acting on this, right? P is still acting on this point P. So after the first order analysis, what we will get? We will get a moment here. We will get a moment here. Okay, so this moment will be how much? This lateral force into height of the column. So it will be V into H. This is my moment. So this is after my first order linear analysis. So I am writing here first order linear analysis. I'm not writing linear analysis. I'm just writing this is the first order analysis we have performed, and we got this moment. Now if you see here, that we got this displaced location of the column, and now the P is not acting at the initial position. The P is acting at this displaced point, I mean displaced location. And this displacement, if I consider delta, okay, this displacement if I consider delta, so you can see that we have this eccentricity delta, or you can say a displacement delta. P is acting here, so P multiplied by delta will be creating another moment. So if I say m1 is equal to, it will be P into delta. This lateral force was creating this moment, but now this P into delta is also developing another moment here. But when we are performing first order linear analysis, we are not able to capture this effect. Especially when the columns are slender on the, or I should say when the structure is slender, okay, and the vertical force is very high sometimes. So in that case, this P delta effect is very much critical, okay, or you can say this P delta you can say analysis is very much required, because if you are not capturing this, you may be avoiding a huge amount of force, or huge amount of, you can say, displacement as well. Okay, so when we will be performing the second order analysis, okay, second order analysis, in that case only we can get this P delta or this moment here. So there will be another moment which will be added to this. So it will be m plus m1, which will be equal to, or let me make it m2. Okay, let me make it m1. It will be m1 plus m2, which is basically, I should write it like this. Suppose m equal to m1 plus m2. Okay, so this is basically VH plus P into delta. Correct? VH plus P into delta. So this is the additional moment we are getting due to the second order analysis. So this is the total moment that we will be getting after the second order analysis. Okay, remember that at this particular point, this effect will only come when the lateral force and the vertical load is acting together, right? Otherwise it will not occur, right? Because this displacement will not be there. So, and if the displacement is not there, the P is acting axially on the column, right? So it will give a different effect. We will be discussing that, right? What we are discussing now is basically big delta. We call it as big delta, right? So this is a global phenomena. So this P delta is a global phenomena. So if we do not have this lateral force, we will not be getting a you can say big delta, and if we do not have this big delta, then we will not get a moment m2, which is causing due to the P into delta, right? Correct? Now the thing is, now suppose we have done one iteration. Okay, we have done one iteration, and after one iteration we got this result. Okay, now if I perform another iteration of the same problem, so what will happen? This was my second order analysis after first iteration. Now suppose after the second iteration I am getting another display shape like this. Okay, so this was delta. Now let us consider this as delta 1. Okay, let us consider this as delta 1. So I'll make it here P delta 1. Okay, so now suppose this was delta 1. Now I have got some more amount of delta, because this V is still acting on this particular point, right? And P is acting here. So now if I say that I'll be getting another moment, additional moment, which will be m3. It will be how much? So I should write it here. It will be P into delta 1 plus delta 2, P into delta 1 plus delta 2. So it will be giving me the, you can say, what would I write? It will be giving me this additional moment actually, right? Additional moment actually. So in this case, the total moment will be, V into H plus P into delta 1 plus delta 2. Okay, or if I write it differently, it is the correct way. Okay, so VH plus P into delta 1 plus delta 2. So this will give me the total moment here. So now if I keep on doing this iteration, at a certain point, what will happen? So suppose I have done first iteration, the second order analysis, I have done the second iteration of the second order analysis, I have done the third iteration, and suppose after finishing certain amount of iteration, I am seeing that there is no change in the result. So that means the result has converged. So I can stop the iteration now. So what will happen? At this particular point, the result in terms of the moment or displacement is not changing. Okay, so I can say this is my final displacement which I can achieve. Okay, this is the final displacement which I can achieve, and when this displacement is there and we have this P acting on this particular point, so final moment that we will be getting, here, okay, M equal to, it will be V into H. I should write this also here. This V is acting, this V is keep on acting. Okay, so I can say this V H, okay, plus P into delta total. Delta total means, so after many iterations, this is the first iteration, second iteration, then we have done suppose some n number of iteration, right? So another iteration, I'm saying this is the total iteration, or you can also write it at delta n. Okay, so for, I can say we can also write it as suppose delta n, and I can say this is my delta n. And after this, the results started converging. That means there is no change in the result. Okay, there is no change in the results of you can say the values of moment and you can say the displacement that you are getting. Okay, so you can stop doing the iteration there. Correct. So what it will do, it will add up some additional moment. It will give you some additional displacement in the structure, right? Which will actually happen when you have a slender structure, a slender column, and you have a very heavy you can say vertical load, a horizontal load is also acting. So in this case, this phenomena will be occurring. But if you do a normal linear first order linear analysis, all this additional moment that we are getting from this P into delta n, we won't be able to you can say cater it here, right? So this is the P delta analysis. And why it is iterative? We need to do iteration until the results started converging. Okay, until the results started converging. Okay, so this is, we call it P big delta analysis. Okay, so this is a global behavior, right? Now there is one more P delta, which is P small delta. So in this case, suppose we have this column. Again, I am saying suppose this is a kind of slender column, because when we have slender structure, slender column, this effect is very predominant. So some P is acting here and no lateral load, I'm saying. Okay, but due to this P only, what will happen? There will be some flexural buckling, or you can say local bending like this. Okay, right? So we will be getting here, due to this, we will be getting here what? We will be getting this delta here, right? So we call it a small delta, right? Now if we perform, so this is the first order analysis we have done. Okay, sorry, it is the first iteration we have done, first iteration. See, if we are not now I'm saying we are performing the second order analysis only, but this is for the local effect. Okay, so in the first order analysis we are not even considering this particular thing. Okay, so now we have performed a second iteration, and what we found that after the second iteration, this was my first value, this is the first displacement, second one I am getting like this. So you can just see, suppose you can just say that this is my delta 1, and now I am getting another one, this, which is delta 2. So like this you can keep on doing, and at some point you will be getting delta n. Okay, you'll be getting delta n, and the results will start converging. That means suppose this is my second iteration, so the results will start converging, and the results will not be changing. Okay, so we need to stop there. Okay, we need to stop there. So these are the two P deltas. One is P big delta, the above one that we have done. So we also call it as P large delta. Okay, and this one we call P small delta. Okay, so due to this P small delta and P large delta, some additional forces will be developed in the structure. Okay, additional reactions will be developed at the support. Okay, so these things need to be take care. This thing is predominant when your structure is slender or the structure is very tall, you have a very high, I can say, gravity load, and you have the lateral force acting on the structure. Okay, so in this case, this P large delta is, you can say, very predominant. In a slender structure, when your gravity load is very high, okay, the gravity load is very high, in this case this P delta small delta is also very predominant. Okay, so if you are performing a P delta analysis, that should take care of, performing a P delta analysis means taking care of this P big delta moment or P big delta forces, and also P small delta forces or P small delta you can say effect. Okay, so this is what P delta analysis is. When we'll be performing P delta analysis, this action, or you can say this phenomena, should be replicated in the structural model, right? So now the thing is, how to do this, so let us go jump into the software program just to show you few things first. So this is my basic model that I have created. I have applied some gravity load here. I've applied some you can say live load and dead load, and I have applied a lateral load here. Okay, so this is a 2D frame, and what I will do, I will first perform a normal analysis that we perform. So we'll go to define commands, perform analysis. I do not need any print. I will go to add, close, and what I will do, I will perform the run analysis. So I will just perform the analysis. Done. Before performing the analysis, what I need to do, I should have done it here. Now see, if I see this P delta analysis, as I said, when it will occur, it will only occur when the gravity load and the, you can say, the vertical load, the gravity load and the lateral load is acting together, right? But when we are creating normal load combination, okay, by adding the values linearly, so I have got some, suppose some force from the dead load A, we have got some force from the live load B, and we have got some, suppose, live load. Okay, and we have got some you can say forces, or the any value, displacement force, whatever it is, we got C, right? So when we are doing normal load combination, we are linearly adding those, so we are doing A plus B plus C, right? But P delta analysis, or P delta, we will get when dead, live, and this lateral load is acting together and giving me one value of displacement force, whatever it is. So maybe it is D. Okay, so if you create a load combination with linear add, so this is my linear addition we are doing. Okay, but we need to have all the load cases in one particular load. Okay, which that means we need to make sure that these three loads are acting together, and we are getting a force when these three loads are acting together. Okay, so if you are finding out the forces or displacement for each you can say load separately and adding it, it will not work. Okay, it will not give you the result that you are expecting from the P delta analysis. So in that case, all three loads should be acting in a single case. Okay, so for that what we can do, we have a option which is repeat load option in the Staad. So repeat load, what it will do, it will create one single load case by repeating the load cases you have. Okay, and it will act as a load case, not load combination. That means it will not be adding up the you can say loads linearly. What it will do, it will consider all three loads together if I am adding these three loads together, and what it will do, it will be giving me the forces. Okay, so what I will do, I'll click on this I can say load case details. I'll click on this load case details and click on add. I think what I have to do, I have to create a load case first. So load case details add, and I will make it, suppose, none, and here I will make the combination. So the initial load combination for P delta, which is you can say given by the code IS 16700. So I'm using this. Suppose 1.2 dead load, 1.2 dead plus 0.5 live, okay, plus, suppose I'm using plus, you can have plus and minus both direction. I am only one direction load I have applied, so plus and minus. So plus 1.5 I'm using lateral, TERAL, lateral. Okay, so this will be my load combination, but I'm creating as case here basically. So I'll just add it. Yes, fine. Now I will click on this. I'll go to add, and I will go to here. There is an option called repeat load, right? I need to add all these loads in this case. So the factor will be 1.2. I'm basically creating a combination, but it is not, we will not be adding up the I can say values from each you can say load case separately. We'll be considering that all these three are acting together, and we'll be getting a single value, right? So will be 0.5, and this is my 1.5. okay, so I'll just click on add here, and you can see this repeat load combination we have created. So I'll just run the analysis, save. So it is done. Go to post processing. Now first of all, what I will do, I just need this load combination here. So let me see the displacement. So you see the displacement here, and for this combination only, okay, I can go to the summary and I can see the maximum displacement that I'm getting along x direction, right? So the maximum displacement I am getting along x direction, it is, you can see 55 mm, right? You can also see by clicking on this annotate button. So if you just click on annotate node, and I think, yeah, node, and I can think global x annotate, you can see the maximum one we are getting 55.266. Somewhere it is showing 55.855. I don't know, is there, yeah, here we are getting 55.855. okay, so this is the maximum value that we are getting. So I will just write it here from the first model, normal general model, or you can say first order linear analysis. We got you can say delta max equal to 55.855, this much mm. okay, though it is very high because I have just taken a it's a general sizing of column like this, very small size. So 55 mm, okay. And if I just try to see the you can say reaction, sorry, if I try to see the maximum moment at the base at the support, so I'll just go to reactions here, and I'll go to summary. And if you see what I am you can say interested here is only the mz, because I am applying the load along x, so the moment will be acting about z axis, right? So maximum mz, if you see, it is 66.649. okay, so I'll just write it here. Mz max is equal to 66 point how much, 66.649. okay, so I'll just add it here, 649 kilonewton meter. okay, so these are the values I have got from the first order analysis. I'll just write it simply, first order analysis. okay, all right, now what I will do, I have created another model here, sorry, here. So this is for P delta. So what I will do, similar load, okay, similar load, I just have to add one load for this repeat load combination. So I'll go to none. Here I will make it 1.2 dead load plus 0.5 live load plus 1.5 my lateral load. okay, so I will just add this, and I will create a repeat load combination by using this option, repeat load. I will add all these three. It will be 1.2, sorry, it will be 1.2, 0.5 and 1.5. okay, I'll just add it. So here I have got the repeat load combination. All the forces are added. Now I will go to analysis, and instead of adding a linear perform analysis command, what I will do, I'll go to define command, and here I will get an option called p delta analysis. Okay, I'll get an option called p delta analysis. So if you want to perform the iterative p delta analysis, okay, so we want to get both the effects, large and small p delta, right? So this is by default, it will be selected in the version I am using. It is 23 version. So I think in the upper version also this will be the similar you can say window you will be getting. So you need to, if you want to get only the large p delta, you can select. So it will also do the iteration. But if you select this, it will do only one iteration. Okay, so do not go for this. You just, this is based on the stiffness, which is not required. Okay, not one iteration. I should not say this. It is depending on how many iterations you are giving. By default, it is one. But this is not. You should not go for this. Okay, though it will be giving the similar result, but the one we are discussing, which is iterative, you can say p delta, so you should go for this. Use large and small p delta, so both the global effect and the local effect will be considered, right? So you select this. For a you can say normal structure, you can go to 20 to 30 iterations. Maybe 20 to 30 iterations not required. At a certain point it will start converging, but you can go with this because ultimately the results will not change. So suppose I will go for, what happened, I think by mistake I've just pressed close, sorry. So p delta, yeah. So what I will do, I will make it you can say 30 iterations. Okay, and what I will do, I'll click on add here. So you can see I have added a p delta analysis command. Okay, so it will perform the second order analysis now, and it will do 30 number of iterations. Okay, so now what I will do, I will just perform the analysis. I'll just go to perform run analysis, save, correct. I'll go to post processing. I need only this load case. Okay, fine. Now if I see the displacement, okay, so I can see the displacement summary here, and if you see the maximum displacement that I am getting now is 56.564. what was it earlier? It was 55.855. okay, so now though I have applied a very small so you can say second order iterative analysis, okay, suppose 30 iterations we have done. The thing is, our structure is very small. I have not applied very high you can say p value. Okay, I have not applied any high p value, and also not applied very high lateral load. So that's why the change is very small here, but still you can see there is a change. Okay, so what I will do here, I will just try to write it, how much I'm getting now. That is 56.564. okay, 56.564. so delta max is equal to 56.564, right, and if I want to see mz max, how much we are getting, mz max, how much we are getting. So suppose I'll go to my reactions, okay, summary, and I'll get this mz max as, you can say 67.557. okay, I'll just add it here, 67.557 kiloliter. You can see now the thing is, the you can say the change is not that much considerable, right? So just to show you, just to make you understand better, what I will do now, I will not change the lateral force, but I will change the vertical load. Suppose I will increase the dead load here from 3 kN per meter to 10 kN per meter in both the cases. Yes, right. And I will also change it in this model. I'll go to analytical modeling, loading, I'll change this dead load to 3 kN/meter to 10. This is some very random value I have taken just to show you 10 kN/meters. Okay, now I will run the analysis first in the basic model. So this is my basic model. I will run the analysis. Okay, post processing. Let us see what we are getting here. So if I see the displacement here, okay, so the displacement I am getting 55.884. Not much have changed in this because I have not changed the lateral force. Correct? It is 55.884. It is the same almost, right? Still let me make another one. Here I am getting, this is my the first case. Second case, by increasing the p value, right? So I will write it here. Here I am getting delta mass as 55.884 mm. Okay, and m2 max as how much? I see here, sorry, not this. If I see my reaction here, summary, so maximum I am getting 66.771. okay, 66.771. so I'll just write it here, 66.771. so not much difference from this, right? Now let me perform the second order analysis here. Okay, run analysis, save, post processing. Let us see what is the difference now. So if I see displacement summary, you can see now it is 57.112. okay, 57.112 lateral, not, I can say here delta max equal to now 57.112, sorry, 112 mm, and m2 max equal to how much? If I see the reaction summary, I'm getting 68.336. it is 68.336. you can see by increasing the gravity load, okay, this thing has not much changed, right? Because we don't have a proper slender column. All the columns are like 3-meter height, so the local effect may not be much higher in this case. So this case has not changed. But when we have performed the you can say second order analysis, it has changed actually. With the increase of the gravity load, it has changed. You can see, right? It has changed. So in our case, our columns are not that slender. The structure is also not much slender. So in this case, you may not be able to see the change significantly. But when you have a very slender, tall structure, when you have a very highly slender column, so in this case, this effect of P delta is very much predominant, which will be visible to you. Okay, which will be visible to you. So this is how you can perform P delta analysis. I have created a frame like this. What you can do, you can create few more you can say stories, right, and make it slender, and then you can check, and you will see how majorly this thing is affecting actually the forces. Okay, so but here also you can see, just by increasing the gravity load, we have not increased the lateral load, right? We have to not increase the lateral load, but just by increasing the gravity load, this we have changed this. I mean, we got the displacement which is higher than it was previously, right? Correct. So what we can say that yes, this P and delta is actually causing an additional I can say additional amount of displacement, or you can say additional amount of movement at the base, right? You can see it is 67.557 to 68.33. So it has changed. Okay, so this is how you can perform P delta analysis in your you can say structure. Okay, so I have shown using, you can say, 𝐸𝑇ABS, Staad Pro. You can also do it in 𝐸𝑇ABS, SAP, whatever software you are using. In every software this thing is there. The main thing is to understand when it is required. Mostly when you have a slender structure, slender column, these things, in that particular case the P delta analysis is a much requirement, because this local and global effect need to be considered in your the additional forces developed due to the local and global effect need to be considered in your analysis and design. Okay, so this is it for up to this for this lecture. If you have any doubt, you can always write me in the comment. Okay, so and those who are watching me watching this lecture in my course, you can always write me in the chat if you have any doubt. I'll surely try to solve it as per my capacity as soon as possible. Thank you, and we'll see you in the next lecture.